Hello students, welcome to this lecture in which we're going to talk about examples of calculations with surface integrals. We introduced this last time, but we didn't do any examples. So in this lecture we'll focus on calculations. So let's think example 1 in which we have to calculate, we have to evaluate the surface integral over sigma of the function x squared ds over the sphere x squared plus y squared plus z squared is equal to 1. So that means that the rho, which is the radius of the sphere, is square root of 1, which is 1. That's what it means for the sphere. And as we noticed before, for the sphere, it's much better to use spherical coordinate system. So since r is 1, it's fixed, so it doesn't really change. Therefore, our function, vector function r, can be written in terms of phi and theta. And it should be, for the x value, it should be rho sine of phi cosine of theta, but our rho is 1, so that means we write sine of phi cosine of theta I, that's x component. Then for the y component, it has to be rho sine of phi sine of theta, but since rho is 1, we get sine of phi sine of theta j. And for the z component, it had to be cosine of phi times rho so rho times cosine of phi, therefore we'll get cosine of phi k. So we got this part. Then since we have our r, we can calculate dr d phi partial with respect to the first variable, and what would be partial with respect, oh, I forgot to say how phi and theta goes. Phi goes between 0 and pi, and theta lies between 0 and 2 pi. Okay. All right, so we have our parameterization. So this plays the role of u, this plays the role of v, and we need to calculate partial with respect to the first variable first. So dr d phi So what do we get if we calculate dr d phi? Let's try to think. So here we're going to get cosine of phi cosine of theta. For this one, we're going to get cosine of phi cosine of theta, sine of theta, sorry. Sine of theta. And for the last one, we're going to get negative sine of phi. Then we need to calculate dr d theta. So dr d theta will be negative sine of phi sine of theta, derivative of this part. For the second component, we're going to get sine of phi cosine of theta, and for the last component we're going to get 0, right? There is no theta present. So then we need to calculate the cross product. We need to calculate the cross product, so we need dr d phi cross dr d theta. So let's try to do that. So we have I, j, and k. Maybe I'll need a little bit more space here. So j and k. So for I we put cosine of phi, cosine of theta, cosine of phi, sine of theta, negative sine of phi. Then we put the second vector, negative sine of phi, sine of theta, sine of phi, cosine of theta, and then we put 0. So we say equal, and we start our calculations. So for the I, we cross out the first column and second column. So we're going to get what we're going to get? We're going to get 0 minus minus, which is plus, so it's sine squared of phi cosine of theta I. Then we put the minus, and for j we cross out the second column, so this would be 0, and we get minus and minus, which is plus, so it's going to be again minus sine squared of phi sine of theta j. And then the last component we get is for k, so we put plus, and we have this times this, which is cosine of phi sine of phi, cosine of phi sine of phi, cosine squared of theta, plus, because this minus and minus will give us plus, so we get plus, and we have what? We have sine of phi, cosine of phi, cosine squared of theta, k. All right. So what do we need to do now? We need to calculate the magnitude of this vector. We need to calculate the magnitude of this vector. So I took some pause because I made a small mistake. So try to figure it out, and let's see what mistake was. The mistake was here I wrote cosine squared, but it's not really true, because this is sine times cosine, this is right, and minus gives us plus, but it should be sine squared over here. So I stopped for a second, tried to check my work, but apparently I made a mistake, so it should be sine cosines and sine squared of theta k. Alright, so but let's try to simplify this expression over here. We have cosine and sine and cosine, so we can factor it out. Cosine, sine, and we have cosine squared plus sine squared. Cosine squared of theta plus sine squared of theta, which is 1. So this term is just cosine of phi sine of phi k. Alright, so this is a term that we're going to use. Alright, so now we need to find the magnitude of this vector. So magnitude of dr d phi cross dr d theta. So it's going to be square root square root from this term squared, so it's going to be sine to the 4 of phi cosine squared of theta, and did I do this one right? Let's just check. So this one was for j, so it was minus and minus, should be an extra minus here, right? Minus and minus, it's a plus, so it should be minus. Okay, but it doesn't really matter because we're still gonna square it. So when we square it, we're gonna get sine to the 4 of phi sine squared of theta plus cosine squared of phi sine squared of phi. And we need to evaluate this expression over here. All right, so how are we gonna do that? Okay, so what we can do, okay, so what can we do? We can factor sine squared of phi out, right? We can factor sine squared of phi, sine squared of phi. So this term will be sine squared of phi plus cosine squared of phi plus sine squared of phi. Sorry, this should be theta. Sine squared of phi sine squared of theta plus cosine squared of phi sine squared of phi. Alright, so over here we can again factor sine squared of phi. So we're going to get sine squared of phi, another sine squared of phi, and then cosine squared of theta plus sine squared of theta will give us 1. Okay, so that means we have sine squared of phi, sine squared of phi, then this sum will give us 1, cosine and sine squared, plus cosine squared of phi sine squared of phi. Alright, so we can again factor sine squared of phi, and we will be left with sine squared plus cosine squared, which is 1. So we get sine of phi as our answer. Maybe I didn't do it the fast way, but we got the we got what we wanted. We got the cross product, then we got the magnitude of cross product. So we can take the vector r over here, our vector r, and take the x component just to calculate the integral. So our integral should be over sigma of x squared ds. So for this x, we can go and take the x component of the r vector. So we can take this term and put it for the r. So we're going to get sine of phi cosine of theta quantity squared. So for x we put that in, then we put sine of phi for our cross product. So we put it here, so it's going to be sine of phi, and we put we put d phi, d theta, since we substituted x for and ds now is d phi, d theta in our new variables. And this is still over region R, and our region R goes for phi and theta. All right, so So we put, so for phi first, for phi we have to go from 0 to pi, for theta we have to go from 0 to 2 pi, and we have sine cubed of phi cosine squared of theta d phi d theta. D phi d theta. Okay. Alright, so now we need to integrate this sine with respect to the phi. So we have an integral from 0 to 2 pi. We have an integral from 0 to pi of sine cubed of phi d phi, and then we have d theta with cosine squared. So cosine squared of theta d theta. So basically what I did, I looked up this integral for sine cubed, just so I wouldn't spend too much time integrating it. Sine cubed of x dx. If you want to integrate this, the answer is 1/3 cosine cubed of x minus cosine of x plus c, but you do it by parts. We've done the sine squared this semester, but I looked up this one, so we're going to put it over here. We're going to get the integral from 0 to 2 pi of 1/3 cosine cubed of x minus cosine of x evaluated from 0 to pi, and we have cosine squared of theta d theta. So let's see what will happen if we're going to plug in pi. If we're going to plug in pi, cosine of pi will be 1 with the minus, so it's negative 1/3, and this cosine of pi will be negative 1, and minus will give us plus 1. Then we put a minus and we plug in 0. Cosine of 0 is 1, so we're going to get we're going to get 1/3 with a minus, and then what else? We have to plug in 0 into cosine, is going to be negative 1. Okay, so what do we get here? We're going to get 2/3, and here we're going to get negative 2/3, but this minus will put a plus on it, so we're going to get 4/3. So 4/3 we can put over here. So that's our separate calculation. So 4/3 goes outside. We have an integral from 0 to 2 pi of cosine squared of theta d theta. And this one we've done a couple of times this semester, but again, if you look up the answer for the integral for cosine squared of x dx, you're going to get 1/2 x minus 1/4 sine of 2x. And we've done it a couple of times this semester, so to save some time, I'll just use this answer for this integral. Okay, so what do we get? We get this integral is equal to, we have 4/3 and we have 1/2 of theta minus 1/4 sine of 2 theta evaluated from 0 to 2 pi. So we get 4/3, then we have 2 pi over 2 will be pi minus 1/4, but if I plug in 2 pi over here, we're going to get sine of 4 pi, but it's just going to be 0. Then we put a minus, and then we plug in Oh, I'm sorry, I put the minus. This should be plus. This should be plus, sorry. All right, so it should be plus. Okay, so this would be 0, and this would be 0 if I plug in 0, because sine of 0 is 0. So that means minus 0. So our answer is 4 pi over 3, and that gives us this surface integral. All right, so we'll continue the surface integrals in the next lecture. We'll do a few more examples.